everybody. Alright, so we are back looking at Briggs 3.4. Last section we talked about different rules for taking the derivative. And so we'll talk about two more today. So we'll talk about the product rule and then the quotient rule. Okay, so the first one we'll talk about is the product rule. The product rule is that if we've got two functions that are both differentiable at some point x, okay, then the derivative of their product, or if we're multiplying the two functions together, and we are taking the derivative of that. Okay, that's another way to think about it. So their derivative is going to be the derivative of the first times the original second, plus the original first times the derivative of the second. Okay? So however your function may be broken up, it'll be some function times another function, and you'll do the derivative of the first times the original second, plus the original first times the derivative of the second. Okay, you can also, here we use the prime notation. You can also show it with your ddx notation. Okay, either way, it's still the same rule. Alright, so we can do an example with that. So we'll find the derivative. We can see here we've got our function g of x, which is this function, times this function. Okay, so we'll take, so g prime of x is going to be the derivative of x plus 1 over x times the original second plus the original first times the derivative of the second. Okay. Alright, so we'll do our derivative of this first piece first. Okay, we'll do that in red. So we've got the derivative of the sum of two functions. So we'll use our sum formula. So it'll be the derivative of each individual piece. Okay, so we'll have the derivative of x which is just going to be 1, okay, plus the derivative of 1 over x. So 1 over x we can actually rewrite as x to the negative 1. Okay, and then we know how to do that. It's the power rule. Okay, whenever you've got a function that's a fraction like that, you can rewrite it so that way the variable in the denominator is to a power, or like a negative power, and then you just do the product, or the exponent rule, or power rule the same way. Okay, so that negative 1 comes down, so negative 1 times x to the negative 2. We don't really have to write the negative 1. Alright, so it'll be that times our original second function, so we'll just rewrite that. Right, and for consistency's sake, let's rewrite this as a negative exponent as well. Alright, and then we'll do the derivative of, or the original first, so plus the original first, times this derivative here that we'll do in purple of our second function. Okay, so we'll also do the same rewrite here. And so the derivative of x will be 1. Then the derivative, it's minus x to the negative 1. So that'll be, the negative 1 will come down, and the minus the negative 1 will be a positive, x to the negative 2. Okay, and then the derivative of 1, that being a constant, is just 0, so we don't write it. Okay, so there, we've done our derivative step, and now we're just going to simplify it. Okay, so multiplying these two together, okay, we get x plus 1 minus x to the negative 1 minus x to the negative 1 minus x to the negative 2 plus x to the negative 3. Alright, and then multiplying the second two together as well, and we get plus x to the negative 1 plus x to the negative 1 plus x to the negative 3. Okay, so we just expanded the two out, and now we can just combine like terms. So we get 2x plus 1 minus x to the negative 2 plus 2x to the negative 3. Okay, which we can rewrite. So anytime you do this, you'll want to rewrite it so it doesn't have the negative exponents. And that is our final answer. Okay. So using these product rule and the quotient rule is when we start talking about having to use multiple derivative rules. Okay, so a lot of times it won't just be, oh, you do this one and it's done. Sometimes it'll be a combination. Like in this case, okay, we had to use the product rule, but we also had to use the sum rule, or the sum difference rule. Okay, and then we had to use derivative of x, power rule, constant rule, okay, and that's common, okay, you just have to take it step by step. Alright, we can do another example. So this will be your more common way to see how questions written. It'll be, here's a function, find its derivative. Okay, most of the time they won't tell you to use the product rule. However, in this case, the instructions specify the product rule because you've got to recognize, hey, so if it's saying to use the product rule, then this must be the way I must be able to write this as the product of two functions. Okay, that's why they did that, direction-wise. So we're taking the derivative and because this function has a variable that's t, when we write our derivative notation, it's the d over dt. Okay, remember that's whatever variable you're taking the derivative, whatever variable the function is used in the function that you're taking the derivative of. Okay, so we're taking the derivative of 1 minus e to the 2t. Alright, so we can rewrite this as the product of two functions. So remember, if you've got the difference of two squares, okay, that being a square there. Alright, we can rewrite it. So it's 1 minus e to the t, 1 plus e to the t. Okay. So we can look at this as the difference of two squares, where it's 1 squared minus e to the t squared. Okay, and use our difference of two squares, and that'll give us our product of two functions. Okay, so now we have our two functions, we can do the product rule with them. Alright, so it'll be derivative of the first times the original second. Here, let me use brackets here just so it's obvious there's a difference. It doesn't matter. just as long as you know that there's a difference. Okay, and then we've got minus the original first times the derivative of the second. All right, so we'll do our derivative here. We'll do this one in red. Okay, so again, this is a, well, difference of two functions. Okay, so derivative of 1, 1's a constant, so that's 0. Okay, so then it's just the derivative of negative e to the t. Well, e to the t, the derivative of e to the t is just e to the t. Okay, so that's just going to be e to the negative t. 1 plus e to the t, leave that one alone, plus 1 minus e to the t, and then we'll take our derivative over here of 1 plus e to the t. Okay, we'll have the same thing where derivative of 1 is still 0, so we won't write it, and then the derivative of e to the t, and again that'll just be e to the t. Okay, so then we can simplify, distribute those e to the t's. So it's negative e to the t minus e to the 2t plus e to the t minus e to the 2t. Okay, these two cancel, and we're left with a negative 2e to the 2t. Okay, so in that one we were again using the product rule, but not only were we using the product rule, we also had to use the sum and difference formula. We had to know the derivative of e to the t, derivative of a constant. Okay, so it's again that combination of the different rules. Alright, but overall you apply the product rule the same way, and then just take each derivative step by step. Okay, look at this function. Alright, well, what is the derivative of that one? Alright, well, that subtraction there tells me I break it up. Okay, well, what is the difference of this one? What is the difference of this, or the derivative of this one? Okay, so just step by step break it up. And that's with any of these derivative problems. Okay. Alright, so there was a product rule. That's if we're multiplying two functions. Okay. Now we'll look at the quotient rule. So if I'm taking the derivative of two functions that are being divided. Okay, so if I've got two functions, f and g, that are differentiable at some point x, and g of x cannot equal 0. Alright, so whatever your denominator function is can't equal 0. Kind of standard at this point. Then our derivative of the two functions of f divided by g, I made a typo, that should be a g, at x exists. And so we're looking at the derivative with respect to x of f divided by g. Alright, so that's given by the original denominator times the derivative of the numerator minus original numerator times the derivative of the denominator. Okay, all that over the denominator squared. Alright, so the product rule, you're using addition. Quotient rule, you're going to use subtraction, and you've got this division step in here. Alright, a common way to remember this is going to be low d high. So low, derivative of the high one, minus high d low, derivative of the low one, over low squared. So low d high minus high d low over low squared. If that works for you, great. If not, and you've got some other little catchphrase or whatever you need to help you remember this formula. Okay, just like for any of our other formulas. That one's just a common one that's used. Okay, so we'll do a couple of examples with it. So our first example, we've got a function here, and we can see that it's the derivative of t squared plus 1 divided by 3t squared minus 2t plus 1. Okay, so we're looking for y prime. All right, so it'll be low d high, so derivative of the numerator, okay, minus the numerator, so high. One of these days I will make it through this video and not accidentally close it out. Alright. Let me put that undo button in a very unfortunate place. Alright, so we had low d high minus high. Now we're doing d low. Okay. Over low squared. Make my parentheses match here because I can't seem to remember which ones I'm using. Alright, so now we'll actually do our derivative step. Okay, so we've got low. Leave that the same. Okay, times the derivative of the numerator. So we're doing the derivative of the sum of two functions. So we'll do the derivative of this one first, so that'll be 2t. Okay, plus the derivative of 1, which is just 0. Okay, minus t squared plus 1. Derivative of this one, and this one is still just a sum and difference. We still just take the derivative step by step. Okay, so we've got 3t squared. That 2 comes down, so 3 times 2 is 6. T to the 1, because 2 minus 1 is just 1. Okay, minus derivative of 2t is just 2. And then the derivative of plus 1 is just a constant, so it's 0. Alright, and all that over alright, and now we can simplify the numerator. You're fine to leave the denominator like it is in the case of these trinomials. Alright, just because it's such a complicated multiplication to try to do. If it's something just a 2 terms, you can go ahead and multiply it out, but the ones with these 3 terms like this, just leave them like that. Okay, so we can expand the numerator out, and we get 6t cubed minus 4t squared plus 2t minus 6t cubed plus 2t squared minus 6t plus 2. Again, all over this denominator. Alright, and we see this, what cancels? Does anything cancel? No, nothing cancels, but we can combine some like terms. Oh wait, nope, these cancel. So these 6's cancel. And then we can combine our squareds and our t's. Alright, we combine everything and we get it down to negative 2t squared minus 4t plus 2 divided by this 3t squared minus 2t plus 1 squared. Okay, and we can leave our answer like this. Alright, so again, that one's not bad. It's just making sure you apply the quotient rule. Okay. So apply the quotient rule, and then again, it's just step by step. Okay, take your derivatives, that combination of rules, simplify what you can. Okay, and then you're done. All right. And then one last example. This one's done a little differently. You might have seen examples done like this in the extra examples for 3.3, but sometimes they might give you a table with all of your derivatives in it. So we've got everything we might need, and we're going to find or evaluate our derivative of this function here. All right. So we'll take it, and the first thing we see is, okay, I'm dividing this by this, so I need to do a quotient rule. Okay, so we'll do that first. So it'll be low derivative of high. Oh, I forgot about the brackets. Minus high d low. Okay, and we can mix notation like this. So if it's just a g of x, we can use the prime. Because we've got the product of the two functions, it's easier to just go ahead and use the d dx. Okay, because we've got this x, we can't just write f prime and then stick an x out there because it's not the same. So it's perfectly okay to mix the two. All right, so we have all that divided by low squared. Okay, and that's all evaluated at x equals 4. Okay, remember if you've got when you're using the d dx notation, you've got the bar and then whatever or wherever the function's being evaluated at. Okay. All right, so we can go step by step, and we can also kind of do a two-step. We can plug in that 4. So we know that this will be G4. Okay, because all we're doing is plugging 4 in for x. We don't have to take a derivative at this step. All right, but we've got to take the derivative of x times f of x. Now, x times f of x is a product of two functions, a function x and a function f of x. All right, so we'll do a product rule in the middle of our quotient rule, which, no big deal, we can do that. Okay, so it's going to be the first. You know what, let's do this in two different steps. Let's put an x back here. We'll do the derivative and then we'll evaluate it. Okay, just make it a little clearer. All right, so we'll do the derivative of the first. No, sorry. Just the original first. Derivative of the second. Okay, plus derivative of the first, so that's just 1 times the original second. Okay, so there's our quotient, or our product rule in the middle of our quotient rule. All right, and then that'll be minus. Okay, and then we'll pick back up with our quotient rule, so it'll be minus x f of x times g prime of x. All right, all that over g of x squared and evaluated at x equals 4. Okay, now we can do that evaluation step, and if you can skip this step if you need to, and you can plug the 4 straight into this step. Totally fine, but I figured for the first time going through one of these where we have to do both of them especially, it'd be easier to do it in 2 separate steps. All right, so we can plug 4 in for this, and so we get g of 4 times 4 times f prime of 4 plus 1, and we can just not write the 1, f of 4 minus 4 times f of 4 times g prime of 4. Okay, divided by g of 4 squared. All right, so we've plugged 4 in for those, and now, because we don't know the functions, we do instead know all of these values. Okay, so I can go and pull my values from the table. So like g of 4 is going to be 3. Okay, f prime of 4 is going to be 1. Okay, so it becomes 3 times 4 times 1 plus 1 times 2. Again, we don't necessarily have to write the ones. We got 4 plus 2 minus 4 times 2 times 1 divided by 3 squared. All right, if we simplify that, it comes down to 10/9. All right, and then again, so if we're using this notation, okay, with the bar saying we're evaluating, once we plug the x equals 4 in, we don't have to write the bar saying that's where we're going to evaluate it at anymore. Just like, it's kind of like with the limit, after we evaluate the limit, we don't write the limit. After we evaluate the derivative, we don't say where we're evaluating it at. Okay? All right, so there's the product and the quotient rule. Make sure you get those formulas memorized. All right, and if you've got any questions, well, there's extra examples. You can look at those and you can let me know. All right.